Hello students, Jai Hind, Vande Mataram. Welcome back to the class of Ravi sir, the easiest and finest way to learn the concepts of mathematics from standard 9 to 12. Students, in our today video lesson of standard 10th, we are going to learn the proof of Pythagoras theorem and its converse. Students, before starting today video lesson, if you are new to this channel, just subscribe and don't forget to hit the bell icon. Okay, first of all, let us see the statement of Pythagoras theorem. The Pythagoras theorem. Okay, so writing the statement over here. Statement of Pythagoras theorem, right? In a right angled triangle, the square of the hypotenuse is equal to the sum of square of any other two sides, right? Students, this is a statement of Pythagoras. In a right angle triangle, the square of hypotenuse is equal to sum of square of other two sides. So drawing a right angle triangle over here, triangle ABC, where angle B is right angle. Okay, so as per the statement, we can write in a right angle triangle, considering the right angle triangle is ABC, right, in which angle B is 90 degree, right? What we want to prove? We want to prove that square of hypotenuse means AC square is equal to sum of square of other two sides, means AB square plus BC square. So we can write hypotenuse square is equal to AB is base, square of base, plus perpendicular. BC is what? Perpendicular. So let us construct from B, draw BD, which is perpendicular on AC, right, student? So let us do the proof over here. So in triangles ABD and triangle ABC, ABD, what is ABD and ABC? We have angle ADB is equal to angle ABC. Both these angles are 90 degree, and angle A is common in both the triangle. Right? So angle ABD and angle ABC are each of 90 degree, and angle A is common in both the triangle ADB and ABC, right, student? So by AA criteria of what? Similarity. These two triangles are similar, right? So triangle ADB similar to triangle ABC. So as per the definition of similarity, AD upon BD is equal to AB upon AC. So doing the cross multiplication, here we are getting what? AB square is equal to AD into AC. Suppose this is result number 1. Okay, similarly we are considering another triangle. In triangles BDC, what is BDC, and in triangle ABC, right? We have angle CDE DB is equal to angle ABC. Again, these angles are what? Having measure 90 degree, and angle C are common, right? So again, by AA criteria of similarity, so by angle similarity criterion, we can write what? Triangle BDC similar to triangle ABC, right? So we can write DC upon BC is equal to BC upon AC. So doing the cross multiplication over here, VAC square is equal to DC into AC. This is result number 2. Now adding result 1 and result 2, here in both the result AC is common, so we can write AB square plus BC square. AC is common terms, so we can write AD plus DC, and AD plus DC is gives the value of AC. So AB square plus BC square is equal to what? AC into AC. So we can write AB square plus BC square is equal to AC square. It means AC square is equal to AB square plus BC square. AC square is what? Hypotenuse. AB square is what? Base. And BC square is what? Perpendicular. Okay student, here we are completing the proof of Pythagoras theorem. Let us move to the converse of Pythagoras theorem. What is converse of Pythagoras theorem? This is just opposite statement of Pythagoras theorem. In Pythagoras theorem, we have to prove AC square is equal to AB square plus BC square, but this time AC square is equal to AB square plus BC square will be given, and we have to prove angle B is 90 degree. So first of all, writing the statement of converse of Pythagoras theorem. In a triangle, if the square of one side is equal to the sum of square of other two sides is equal to the sum of square of other two sides, sum of squares of other two sides, then the angle opposite to angle, what is, then the angle opposite to the side is a right angle. Okay, so as per the statement, drawing the figure over here, triangle ABC is given, but we don't know that angle B is 90 degree or not, right? Just we are drawing this triangle. So as per the statement, we have given that a triangle, in a triangle ABC, such that AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square, right? So first of all, constructing a similar triangle to ABC. So constructing triangle DEF, triangle DEF, right? This is just similar to ABC. Okay student, so this triangle DEF should be such that DE is equal to AB, EF is equal to BC, and EF is equal to what, student? BC, right? Here in triangle DEF, angle E is 90 degree. Angle E is 90 degree. So we can use the Pythagoras theorem. And in Pythagoras theorem, applying the Pythagoras theorem writing the proof, in order to prove, what do you want to prove? Angle B is 90 degree. Okay, so it is sufficient to prove. What we can prove? We can prove E is 90 degree, so B will be 90 degree. So it is sufficient to prove triangle ABC is similar to DEF, right? If we can prove ABC is similar to DEF, then we can prove what? Angle E will be equal to angle B. So since angle DEF is a right angle triangle, angle DEF is a right angled triangle, so we can apply the Pythagoras theorem over here. So therefore, by Pythagoras theorem, DF square is equal to DE square plus EF square, where DE is equal to what? AB square, and EF square is equal to BC square. So this is equal to AC square. So here we can write D is equal to AB and EF is equal to BC. So DF square will be equal to AC square, because AB square plus BC square is equal to AC square. It is already given in the statement. So DF is equal to AC. Thus in triangle ABC, we can, in triangle ABC and DEF, we can conclude that angle AB is side AB is equal to DE, side BC is equal to EF, and side AC is equal to DF. So by SSS, it means these two triangles are congruent, and congruent triangles is always similar, right? So by SS criteria, triangle ABC congruent to triangle DEF, and if these two triangles are congruent, then these triangles are similar. Congruent triangle is always similar. So we can write angle B is equal to angle E. We know that angle E is 90 degree. So by CPCT, congruent part of congruent triangle is always congruent. So here angle E is 90 degree, therefore angle B will be 90 degree. Okay student, in this video lecture we have done the proof of Pythagoras theorem and its converse. I hope you have understood this video lesson. For more video lesson, keep watching your channel Ravi Sir Ji Maths. Thank you once again students for watching this video till the end.